So for this video I've got the drone hooked up to the ground station over here. This is running Mission Planner, which is connected to the flight controller, which is running RG Pilot. The flight controller is a Navio 2 flight controller with a Raspberry Pi version 4 Model B with 1 GB of RAM. And this is all being currently linked over Wi-Fi. But eventually the plan is to use radio telemetry instead, so that I can do flights outside of my house, basically. So for this stress test, we're going to have all 4 of the motors run at a high throttle percentage, basically just to test if the hardware is capable of having the drone pull a lot of amps at the same time. With props, these should all pull about 20 to 25 amps each. So the current configuration is a bit overkill. The PDB can withstand 200 amps, and each of the ESCs can do up to 35 amps. So a bit of a upper margin there, just for safety. So to do this test, we're going to go over here to the Mission Planner on the ground station. Go to Setup, and then select Optional Hardware, where we got the test subsection. And I haven't fully calibrated all of the ESCs just yet, so you might not see all 4 of the motors spin up at the same time. You might see a bit of a sort of ripple effect, I guess, but that's completely fine. That'll be fixed in the future. So we're going to go to throttle and then set that to 95%. Mission Planner actually limits the max throttle to I think it's 95%, because apparently ESCs have a dead zone in the top high percentage of it. We're going to do a half-a-minute test, and I'm going to press the test level. In 3, 2, 1. Okay, so all 4 of the motors actually spun up at the same time, so that's good news. And they all sound the same. They appear to be running at the same speed, which is also what you want. Seems to be handling it very well. In about 30 seconds. So I guess you can call that test a resounding success. So from here I'm going to be working on the battery mount, because right now I haven't actually got a mount set up yet. It'll be quite simple, basically just straps and maybe some kind of 3D printed cage just to sort of hold it in position. But I'll be using the stock Tarot 650. Well, you can either use it as a battery mount or a flight control mount. It works either way. It's a carbon fiber reinforced plastic CNC'd sort of plate that you can mount the battery onto. And I'm not quite sure yet if I'm going to make or buy a anti-vibration mount for the first flight. It probably is a good idea too, because I don't want the drone to do something really stupid, because I can be asked to be patient to install one of those, and I'd rather be on the safe side than to lose a drone on its first flight. But other than that, we are getting very close to the first test flight. I'm aiming for about July, early July right now, but obviously that still depends on a number of things, and that's all a bit of software stuff that I need to configure, especially with the transmitter and configuring the failsafe so it doesn't constantly activate. And yeah, but hopefully we can expect a first flight sometime soon. Thanks for watching, and goodbye.